Hey guys, so we are going to um, be doing system of equations today. It's not that difficult. We're going to be using a calculator for a lot of this, and we're just trying to find the intersection. So in terms for system of equations, let me see if I can write something on here. System of equations are two or more, two or more equations on the same graph. I'm just going to put EQ for equations on the same graph. Now, a solution will depend on how many times they intersect. How many times the lines intersect. The lines intersect. Okay. Now, the normal type that you're going to see is this middle one here. This is called one solution. They're going to ask you, there's going to be three different types of solutions. So this is one solution. And this happens when the lines touch once. It usually looks kind of like an X or a cross or like a squish thing or whatever, but they only touch at one point. So this would be here. Now, not only do you have to write one solution, but you would also have to write the answer of the point where they touch. So you just kind of count and see where they hit. So let's see, -1, -2, comma, and I got to go up just one, right? Yeah, so +1. So -2, comma, +1. Pretty simple, right? Now, the one on the right, if you notice, there's two lines overlapping. And this is actually infinite solutions, and I'm going to explain why here in a sec. Infinite solutions. And that is because if you notice, we talked about how a solution is where they touch. And if you notice, let's say we have these two lines here, they would touch at this point, right? Because they're overlapping. And they would also touch at this point because they're overlapping. And you would touch at this point. Pretty much they would touch at every single point throughout the whole thing. So because of that, it's infinite, if that makes sense, because it's never ending. And then the last type over here on the left, this is no solution because they are not touching and they never will touch. This is no solution. And the reason for that is because they have the same slope, but they start at different places. This one's higher up. It starts at +2. This one's lower down. It's at -3, but they just go up the same amount. So since they go up with the same amount, they're never going to touch. Okay, so let's move on to actually graphing and actually trying to find these solutions here. Now, what I'm going to be doing is I'm going to probably do half and half when we graph. I'm going to do one of them by hand, and then I'll do the other one on the calculator. And when we get to more difficult problems, we'll do the calculator, okay? What do you notice about the solutions to each of the systems of the equations above? We already explained that. Let's move on to example 1. Now, for the top ones, what I'm going to do is I'm going to graph these by hand, for those of you that know how to graph by hand. And the bottom ones I will graph on the calculator because they are not in y equals mx plus b form. The easiest way to graph by hand is probably y equals mx plus b form or point slope form. So if you remember, the number in front of your x is m, which is your slope, and the number after your x is your b. So your b, this number right here, is where you're going to start on the graph on the y-axis. So I'm going to start on +1. So I'm going to go up to +1 on the y-axis, and draw my first point. Then I'm going to do rise over run for my slope to get my second point, and that'll be my first line. So let's see, this is -1. So when we have a negative, instead of going up 1, we are going to be going down 1. So we go down once, and then we will always go to the right for the bottom number. So we're going to go to the right 3. 1, 2, 3. We stop there. That's where we have our second point. If you look closely, it's on the number 3 on my x-axis, right? And now we try to make a line as best as possible, as straight as possible. If you want to try to use a calculator or something like that that has a straight edge, I think I have some rulers in the red bin by the Mario and Donkey Kong poster. Okay, and now I need to get a second line to see what type this is. So I'm going to get my calculator. I'm going to go to add graph. And since my equation is not in y equals mx plus b form, I'm going to have to use nsolve for this. I'm going to move this thing over here. So N S O L V E. Make sure you spell solve right. Some people were accidentally getting it wrong just because they forgot how to spell solve right. So take your time. If it's not popping up, go recheck your equation and your spelling, okay? Open parentheses, and we're going to type our equation for this, y plus 6 equals 2x. Y plus 6 equals 2x. And then at the end, we have to put what? Comma y, right? I'm sure a lot of y'all remember that. And then close parentheses. We're going to press enter. Now, what we are going to focus on to turn this graph to be able to draw it on our paper is where it hits the x-axis and where it hits the y-axis, okay? And we're going to draw a point, 2 points, one for the x where it hits the x, one where it hits the y, right? So if you notice, it actually hits it right here at 3 on the x-axis. So I'm going to change to a different color. Obviously, your pencils can't do that, but I'm going to change to a different color so you can see it better. So my first point is on 3 on the x-axis, which is actually on the same point for the blue line, right? And then for the y-axis, it hits at -1, 2, 3, 4, 5, 6. -6 on the y. I got to count down. 1, 2, 3, 4, 5, 6. Draw your point here on -6. Now I have to connect these two as best as possible. Oh, that was really bad. There we go. Now, in terms of drawing the graphs, I do want you to um, take your time to make sure you try to do these as straight as possible because um, a lot of times for those of you that have to take the STAR test, which is coming up pretty soon actually in December, they will have on the test blank graphs and you're going to have to draw them accurately. And they're going to look, and if it's not accurate, they will not give you points for it. So take your time to make sure you kind of connect the dots and make the line as straight as possible. Okay, it's really important, guys. All right, so I have my two lines. Well, what is my solution? My solution is where they touch, and that's actually, lucky for us, the easy part because we know that they touch right here at 3 on the x-axis, but we have to write that as a point. So if you remember on the x-axis, my number will go first. So 3 will go first, comma. Does it move up or down at all? No, it doesn't. So it is 0, 3 comma 0. Okay, let's move on to the second one. Let me get a different color. Okay, so I'm going to do example 2. Same thing, this is my M, and then this is my B. So on my y-axis, we're going to start by drawing the first point on the y-axis at +2. The symbol is very important. That's in front of the number. So I have to go up 2. If it was negative, we would have to go down 2. Draw your point there. Okay, and then my slope, again, is negative, so we're going to have to go down 3. Go down 3, because it's rise over run. 1, 2, 3. And to the right 2. 1, 2. That's where we stop, and we're going to draw our point. So our point should be at, our second point should be at +2, -1, if you did it right. And we're going to take our time to try to draw this straight. Doesn't have to be perfect, but it has to be decent. It can't look like garbage, guys. All right, and then we are going to graph this part, the bottom one, into the end solve, right? So I'm going to back out of this. I'm going to click X and no. Get used to doing that every time to reset your problems, okay? Get used to clicking the red X at the top. I know we used to press home a lot, but since we're doing a lot of lists and spreadsheets, let's get used to clicking the red X. So add graph, we're going to do nsolve, NSOLVE, open parentheses. I'm going to type my equation, y minus 1/4. Okay, so y minus, and to get the fraction, remember it's control and then division symbol. We get our fraction. So 1/4. To get out of the fraction, you have to press the right arrow. X equals, and I forgot what the last number was, equals something, -5. And be careful when you're looking at your equation. A lot of you will accidentally forget to put the negatives. You'll have like almost the same thing, but then you put equals 5, which will give you a completely different graph. So make sure you double check where the negatives are, because I know sometimes it's hard to see with like longer equations that the minus symbol's there. Okay, so take your time when you're looking. So we have comma y, close parentheses, press enter. Now we cannot see where it hits the x-axis, which is kind of crazy. We do see on the y-axis it hits at -1, 2, 3, 4, 5. So let's do with that first. So you're not like overwhelmed. Let's just do with what we know. Um, let's make this green. So -5, right? So let's go down 5 from the middle. 1, 2, 3, 4, 5. Now our line doesn't even go out 10. I mean, you could probably guess that, right? This thing isn't going out to like 30. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, it only goes to 10. So what we're going to do, is my calculator, is do Control T to find a second point. Okay? If this is only when you can't see where it hits the x-axis, or if you can't see where it hits the y-axis, right? We have to get another random point somehow to draw this line accurately. So Control T, and you're going to look for any number that is not a decimal. So right here, 4 comma -4, there's no decimal after that, right? It's not like 0.78 or something like that, because always 0.75s, 0.25s, it's going to be hard to graph, right? This one is not. 4 comma -4. So we can plot that. So we're going to go to the right 4. 1, 2, 3, 4. And then -4, we're going to go down 4. 1, 2, 3, 4. So right here. So all we need is 2 points. Then from here, we're going to do our best to draw our line as straight as possible. A little bit low. Something like this. something like that. I know that was pretty bad. Now, our intersection is right here. Now, it looks like it could be on a decimal. Um, I would just make it as accurate as possible. It's a little bit below this point. So let's see. So 1, 2, 3. So positive 3, comma, negative 1, 2, 3, 4. And it's a little bit below that. So maybe negative 4.2 or something like that. Now, let's say you hate doing this by hand, right? Like drawing the first graph by hand. Um, I'm going to use this example too for those of you that like graphs only, using the calculator only. Let me get out of that. So I'm going to do Control T to get out of it. You could actually press Tab and graph the other equation, and it'll do it for you on the calculator. Let me erase all this other stuff so you can see it better. So if you press Tab, you can do the other equation. So nsolve, NSOLVE, open parentheses, and we did the first one by hand, right? So you can't put f of x though. That doesn't work. You have to put y. Okay. So it's y equals. So I'm going to do the top equation to show you if you don't like doing anything by hand. So I'm just still doing example 2, but I'm doing it all calculator real quick. So y equals negative 3 over 2x, negative control division symbol to get the fraction, 3 over 2. I got to get out of the fraction, so move the arrow key to the right, x plus 2. And we graphed this by hand already, but in case you don't want to do any of that, and then comma y. It was the same equation. It's going to make the same line, but here's the difference, right? That way you can graph this how you want um, by looking at the x and y axis. And sometimes this will still work. We're going to try it out. Menu 6, 4. It's supposed to get where they touch the intersection. Okay. Now, might not always work because some of the calculators are old and glitchy. So menu 6, 4. So this part's kind of weird. So you have like this line, right? So you can move it around if you notice. It says lower bound. You want to go to the left side of where they touch. Not too far. I wouldn't go too far. But you don't want to be on it. So then you will click the middle button here on your calculator. And then if you move it again, you can see you drag it. So you want the intersection to be in this gray area. Your calculators will be very slow at this. It'll take some time, it'll think, and then it'll maybe move a little bit, and then it'll take some time, then it'll think again. That's why you want to get close to it, because the further you have to go, the longer it will take, and for some of you, it might freeze. And if you notice, look here, I have the intersection, 4 comma negative 4. So the calculator is more accurate. So I think ours was a little bit off because when we were drawing our line, maybe I was a little bit crooked. So you can see how that can make a difference, right? If your line's somewhat crooked, you can get the wrong answer. So the answer for number 2 is actually 4 comma negative 4. Because I know we had what, like negative 3 comma something, so that's wrong. It's negative, or sorry, it's 4 comma negative 4. So if you really want to recheck, or maybe you just want to do calculator because it's easier and more accurate, do the calculator way. Okay. Okay, let's move to the back of the paper. Okay, this is backwards. This is actually, for those of you that like to get the equation from the graph, would be easier. So my equation one, I'm going to make this the red. So for y'all, it's the one that's higher up. For me, it's red. I have red and green. So what I'm going to do is I am going to put them into y equals mx plus b form. Okay, mx plus b. They want you to get the graph, each line, and turn it into an equation. So I know at b is the y-intercept. And that's easy. It's right here. It touches the y-axis at, I think it's 6. 1, 2, 3, 4, 5. Yeah, it's 6. So I know b is 6. So I don't know m yet, so I'll leave that blank. X plus 6. Now I can get another point anywhere that's on an intersection. We have to look kind of carefully to make sure it's perfectly on an intersection. I think this one is right here. And we got to do rise over run. So I'm going to go up 1, 2, 3, 4, 5. So that's my rise over my run, which is 1, 2, 3. So 5 over 3. So there's my red equation. Now equation 2 is going to be your lower line. This is going to be your green. Same concept, right? So for my y-axis, it hits down here at -1. So y equals, I don't know this yet, x. To this -1, we can put -1. And let's see here, we want an intersection. There's an intersection actually really close to it right here. So we just got to go up once. So up 1 and over 1, 2. So 1/2. So 1/2 x minus 1. Now lastly, they want the solution. So it's just the intersection right here. That should be easy. We're just plotting the point. So let's see if we go left 1, 2, 3, 4, 5, -6, and then go down 1, 2, 3, 4, -4. For the solution, we're just putting where the point hits. Okay. Okay, and then for the last one, if you want to get the solution first, that's fine. Since you're like, oh, that's really easy, I just got to put the point. Then let's do the solution part first. Let's see, -1, -2 on the x. So -2, and then I go up 2, so +2. So there's my solution. Now it's saying which two equations represent the lines. And there's a whole bunch of equations. Only two of them work. You could guess and check on the calculator, but I think that's like not a waste of time, but there's a really easy way to get rid of like half of these answers. Just look at the y-intercepts. What point is this on? This is on 1, 2, 3. This is on a +4. And let's take a look at the other one. What point is this bottom one on? Let's see, 0. This is on -1. Remember, the y-intercepts are b, which means either +4 or -1 should be the number at the end. So anything that's not +4, or if it doesn't have a -1 at the end, we get rid of. So this is +4, this is good. This is -4, that's wrong. -1, okay. +1, that's wrong. -4, that's wrong. Should be +4. +1, that's wrong. Should be -1. Yeah, so we legit got rid of half of the answers. So now we just got to figure out Now, do you really have to count this? You could do rise over run. Sure, you could. Or if you think outside the box, you don't have to do any math for this. If you look at your line that has +4, what type of slope is this, guys? If it's going up, is this a positive slope or a negative slope? This is a positive slope, isn't it? So the +4, the number for x should be positive, shouldn't it? So the number in front of x should be a positive number. This is negative. That's not positive, so that's wrong. So this is your answer for the top line. And then for the second line, you see this line is going down. So that means this is negative. So the number in front of x needs to be negative. Is this number negative? No, it's not. It needs to be negative. So that means this is your line for the blue. See? And all it took was counting up or down and looking at the line if it's going up or going down. Nothing crazy. Okay. Okay, there is a 6 question assignment on Schoology. I would probably use your calculator for most all of it, since on Schoology you can't really draw on it. I think you might be able to, but that's up to you. I would still use a calculator for some of it. Okay, I will see you all next week. Behave and have a good weekend. Bye, guys.